Hello, hi, good morning my dear students. So in this video we are going to solve the numerical problems of chemical kinetics. So in the last videos we have been observing the theoretical parts, and this is the first time we are solving the problems. So here in this chapter, as well as the theoretical part, the problems are also most important because it will be asked 2 or 3 marks. So you are not supposed to have the negligence. So it is also important. Okay. So let's begin the problem in chemical kinetics. And before this one, you are already know that the problems of calculating the order of the reaction, it will be asked for 1 mark or sometimes it is 2 marks. I hope you are already familiar because in the theoretical part only I have given some of the homeworks. So coming to the problems, so let's begin from first, zero order and first order. So these are the formula. This is the first order reaction and half-life of first order. This is zero order reaction and half-life of the zero order reactions. So based on these two, we will solve the problems. And I have already sent you the notes. You just refer the notes, and in that total 5 problems are there. In that I am going to solve you first, third and fifth, and remaining 2 and 4 are the not homework because already you are having the answers. So I hope you can able to understand that by seeing the notes. Okay. So let's begin first one. I hope you have already note down the problems. So if you are written somewhere in the problem, you can able to understand the answers. So let's start. The problem first one is calculate the times. Calculate the time in seconds for the decomposition of N2O5, which follows first order kinetics when concentration of N2O5 is dropped from 0.1 m to 0.01 m. M means molar, and given is K is equal to, means rate constant is 6.22 into 10 raised to minus 4 per second. They have given in the given concept. This problem follows the first order reactions, and they are asking you to calculate the time in the second. So here they have given the initial concentration and final concentration with rate constant. So let's start from the given data. Solution for first one. Given data. So given is what they have given. They have given T is the question mark. T have to calculate. And they have mentioned you the first thing, it is a first order reaction, that is why the rate constant K is having the SI unit per second. Most of you know where somewhere disturbed or you were not able to understand some of the numerical problem in I think that order of the reactions. How means the first order and zero order can be calculated by referring the SI units. Can you see here in this problem, K is equal to 6.02 into 10 raised to minus 4 per second. That SI unit of per second of rate constant, that itself indicates that the reaction follows first order. So this is important. And here they have given 0.1 m. 0.1 m concentration is concentration of R naught. Initial concentration is 0.1 m, and concentration at time t it becomes R. Then it follows to 0.01 m, where K they have given 6.22 into 10 raised to minus 4 SI unit is per second. And what they have asked to calculate the time. Is this clear? So they have mentioned that the reaction follows first order reaction. First order reaction means according to first order reaction, we know that the rate constant K is equal to 2.303 divided by T log R naught upon R. Means K they have given already, we know that, and T we need to calculate. R naught they have given initial concentration, R is the concentration after some time T. So using this formula by rearranging K, we know that T we have to calculate. Therefore we will shift T to the left side and we will bring this K to the right side. Therefore T is equal to 2.303 divided by K log R naught divided by R. Is this clear? we will now substitute the data. T is equal to 2.303 as it is, where K is nothing but 6.22 into 10 raised to minus 4. Therefore 2.303 divided by K is nothing but 6.22 into 10 raised to minus 4 log R0 is nothing but initial concentration, that is 0.1 divided by 0.01. So we will begin to solve this one. 2.303 divided by 6.22. First you have to, by using your calculator, first you have to divide 2.303 divided by 6.22. First you have to divide these two terms. Whichever answer you are getting, you have to write here, and the remaining is 10 raised to minus 4 from numerator to the, it comes to the denominator. I mean, when it comes to the upside, it becomes minus 4 is converted as 10 raised to plus 4. It forms plus 4. Denominator to the numerator, and minus 4 is converted as plus 4. And 2.303 divided by 6.22 is 0.37025. 0.37025. So some still extended numbers are there, but we have taken only this much. 0.37025 into 10 raised to 4, and remaining log 0.1 divided by 0.01 is log 10. Log 10 means 0.1 divided by 0.01, it becomes 10 value. So here, so we will keep this number as it is, 0.37025, 10 raised to 4. By shifting this number to this side, it becomes, better you keep the same thing here only. 10 raised to 4 is as it is, but log 10 value is 1. Log 10 value is 1. Therefore, anything into 1 is as it is. Therefore, 0.37025 into 1 means same thing, into 10 raised to 4 as it is. So we know that according to the scientific notation, we have to do the answers first by non-zero point. So we will shift this point to the side. 3.7025 into 10 raised to. Here we have increased the number by 1 digit. Therefore, we have to reduce the number of power by 1 digit. Therefore, 4 is converted as 3. This is time. Time should be in second. While writing the final answer, you are not supposed to neglect the writing of assignment. If you are neglected means you are going to lose fraction, half or sometimes more marks, because the representation of the final answer along with the assignment is most important. I hope you are understood. Look here, for every time by solving any of the problem, must and should first you have to write the given data. To the given data, you are not supposed to write the given data directly in the formula. Means soon after writing the given data, you have to write the formula. After writing the formula, you have to substitute the given data. And after substituting, suddenly you can have the final answer. But you are not supposed to skip these methods. Given data, formula, substitution, then directly you can write the answers. But compulsorily you have to write the formula separately, and substitution and given data. These are important, and writing the assignment is most important. I hope, is this clear? And we will move to the next one. So second one is very much easy because you can able to solve. Here they asked you to calculate the half-life of first order. First you have to calculate the rate constant to calculate the half-life. Therefore, by using the rate constant, the same formula, you have to calculate the K value. After calculating K value, you have to calculate the half-life of first order. So I hope you can able to understand this one very easily. So coming to the third one, the third problem, the reaction is first order rate constant of 2.90 into 10 raised to minus 4 per second at a given set of condition. Find the concentration of SO2Cl2 at 865 seconds when initial concentration of reactant is 0.0225 molar. So here they have given some of the problem. Try to write given data. In the third problem, the given data they have given that while taking the reactant to the product, they have given the initial concentration. They have given initial concentration, but they are asking us to calculate the concentration at a time, some time. That time they have given already 865 seconds. And while writing the second, you are not supposed to write SEC. In the notes, it is by mistake it has happened, but you have to write only S, small letter S. That is the assignment of second, not SEC. Okay. They have given the time, and they have given also the rate constant. So using these all things, you have to calculate R and R naught. They are the two terms. R naught is the initial concentration, R is the concentration at some time. So in this reaction, they have given you the initial concentration, whereas solution given data, initial concentration they have given as R naught. The concentration, initial concentration is 0.0225 molar, whereas they asked you to calculate the concentration of SO2Cl2. It means it is the concentration of R at some time. They have given that. Find the concentration of SO2Cl2 at 865 seconds. It means at the initial concentration is nothing but when the time is 0. That is considered as R naught. This is how they are given initial concentration. It means at the time is 0. When the time T is equal to 865 seconds, then R naught is converted as R, means at this time the concentration is 1. That's why they have asked to calculate the concentration of R at time 865 seconds, and they have given initial concentration, and also they have given the first order rate constant is 2.90 into 10 raised to minus 4 second. K rate constant is taken, but K is equal to 2.90 into 10 raised to minus 4. The SI is they have given per second. SI is per second. So here also note they have already given the reactions carry out in the first order reaction. So first order reaction is nothing but K is equal to 2.03 divided by T log R naught by R. So here what we have to calculate R. So we will just rearrange this equation. How means we are going to keep the log R naught by R here only, and we are setting T and 2.03 to the left side. This T comes beside K and 2.303 comes below the KT. Therefore, I hope I am getting my point. Log R naught divided by R. Log R naught divided by R. I am keeping this log as it is and sending this 2.303 divided by T to the right side. It is divisible. It is having the function divided by. Therefore, it takes a multiplication. This is having multiplication. It comes in the denominator form. K into T divided by 2.303. I hope this is clear. If you are having still more doubts, go through once again. Otherwise, I will be there to clear your doubts. So let's substitute the values. Log R naught is nothing but nothing but 0.0225 divided by concentration of R as it is, but because we don't know, we have to calculate that one, is equal to KT. K is nothing but 2.90 into 10 raised to 2.90 into 10 raised to minus 4 into K into T. T is nothing but 865 seconds divided by 2.303 divided by 2.303. So here the multiplication of these two, while doing the calculator, look here, first you have to calculate from your calculator. Please don't use the scientific calculator because it is not allowed in your annual exam. Even though you are having, please don't use that one. So use the normal calculator, which is citizen, larger one, so it is convenient. So in your calculator, first you just 2.90 into 865. You just do the multiplication, 2.90 into 865. You are getting some value and just put the is equal to. You are getting value, and to that value, after putting is equal to that answer, you just put the divided by 2.303 and then put the is equal to. You are going to get the value. That value is 1089.2. Some of you may feel that I am explaining in a low level. No, because while in urgency you may have the problem 2.9 into 865. Directly if you put the divided means you are going to get the wrong answer. That's why first you have to do the multiplication of these two and you have to say that is equal to button. Then after by dividing that one you can get the correct answer. If you want still more confusion means do it separately. 2.90 into 865 you write that answer support and again write the 2.303. Why I am writing means you should be capable of even though you are having that calculator, you are not have you no need of extending your time, so you can less time you can able to solve the more number of problems. That's why I am telling you multiplying this 2 is equal to and again divided by 2.303. You are going to get the answer, and 10 raised to minus 4 as it is I have kept here, and here log same thing 0.0225 divided by concentration of R. We are getting some value. Here it is log. We know that while taking plus, if it is moves to the right side it becomes minus, into if it is comes to the right side it forms divided by, square root if it is comes here it forms the square. I hope this one you are familiar with this concept. Similarly here, if the log is converted bring to the right side, the log becomes anti-log. Therefore I am sending this only log, not the other number. Log when it comes to the right side it forms anti-log. Remaining number as it is 0.0225 divided by concentration of R is equal to log becomes anti-log 1089.2 into 10 raised to minus 4. So you may write this minus 4 as it is, otherwise by dividing this you may get 0.1089. I hope you can able to understand this one. 0.1089, and anti-log of this value is if you are familiar about the log table to determine the log and anti-log, it's very nice. If you are not having the log, so must and should you have to purchase, because by log table only you should be capable to solve the log and anti-log. Otherwise in the normal calculator also it is possible to calculate the log value, but I am not sure about the anti-log because by some mechanical process it is possible to calculate the log table in a normal calculator also. When you are comes to me in the classroom I will explain that one. Okay, so here the anti-log of this value is 1.285. So we need R, therefore we will send R to this side and we will take this 1.288 here. Therefore 0.0225 divided by this value comes here 1.285 and R comes to the side. So dividing these two we are going to get R. Here R is nothing but what? SO2Cl2 itself. So R is nothing but concentration of the reactant at some time. That's right. SO2Cl2 at 865 seconds. The value is, by dividing this one we are going to get the value 0.0175. 0.0175. My dear students, Again the same thing. While writing the final answer, you are not supposed to mistake the assignment, because we are writing the concentration of reactant. The concentration, it may be a molar, sometimes it may be different. How you come to know means in the reactions initially they have given the initial concentration, if it is M, so it will be M only. If they have given some different concentration means whichever they have given the another concentrations assignment, the same assignment unit we have to use. Okay, I hope this is not much difficulty. Given data, rearrange the formula by substituting this one, and we are sending log to the anti-log. By doing anti-log, we are getting some value, and by rearrangement, we are getting the R value. This R value itself is the concentration of SO2Cl2, means concentration at some time. The value is 0.0175 molar. So this is the third one. Probably at most of the time they are not asking you. The most of the previous question paper also they never ask you such kind of the problems, but there is a tendency to ask. So that's why be thorough by practicing the same problems. So it will be never asked little different or some other than difficulty problems will never be arises in this chapter. So this is one of the difficulty chapter. I mean difficulty problems. Only this one, because you may feel the difficulty in calculating, and you know otherwise it is very easy, and it is not oftenly asked, but it is there in the model question. That's all. So and fourth one is homework for you, because it's very simple problem. And coming to the fifth one, in the fifth one they have given the rate constant for a first order reaction is 60 per second. Rate constant means K they have given. K is equal to how much? Given data. Solution. Small K is equal to, they have given 60 second. 60 second. And they are telling that the rate constant for first order is first order. How much time will it take to reduce the initial concentration of the reactant to its 1/16th time? You just concentrate once again the problem. They are not asked you to calculate the half-life, not exactly half. They are asking you how much time will it take to reduce the initial concentration. Think that if they have given that, calculate the time required to reduce the initial concentration to exactly half of the initial concentration. It means that it is half-life, but they are asking that to calculate the time when the initial concentration is reduced to the its 1/16th time. 1/16th time means it's not the half-life. It's not half-life. So that, but they have not given what is the concentration. Its initial concentration they have not given, but simply they have given it is reduced to the 1/16th time, 1/16. Therefore, we will take the initial concentration as 1 by assuming that the initial concentration is 1. We will take, but they have not given. We are taking the initial concentration, we are taking as 1, and the concentration of the reactant at some time. We don't know that time, that's why we are calculating T. It's not T half, it's simply a T. Therefore, at what time the concentration of reactant, initial concentration is reduces to 1/16th time. That is the question. K they have given actually initial concentration is nothing but 1. When this initial concentration is reduces to 1/16th time, how much time it takes to reduce 1 to 1/16th time? So this is what we have to calculate. So in question they have clearly mentioned this reaction carries first order reaction. Therefore K is equal to first problem, first equation. So here we need to calculate T. So by rearranging that one, T is equal to what? 2.303 as it is. This K is sending to the right side. Therefore K into log R0 upon R. R0 upon R. So in the notes I have not mentioned the formula directly. I have some student, please don't do that mistake. If it is to some mistake means you just recover that, but don't continue the problem or that mistakes. Okay. T is equal to 2.303 as it is divided by K. K is nothing but 60. 2.303 divided by K. K is nothing but 60. into log R naught is nothing but 1, log 1 divided by R is nothing but 1 by 16, 1 by 16, 1 by 16. For your kind information, look here, A upon B divided by P upon Q. If it is there, we can write this A upon B as it is, the divide converted as into, and the Q it's moving to the up. Therefore, Q divided by P. I hope such kind of problems are very familiar in your mathematics and sometimes in the physics, but this is very common for the mathematics students. Just I would like to remind you, based on this, here nothing is there. I mean, below 1 nothing is there means it is understood 1 will be there. 1 is there means 1 divided by 1 and whole divided by 1 by 16. Therefore, we are here in this one 2.303 divided by 16 first, but we have calculated this first, and log the 16 comes to the upside. Q is the thing of 16 here, Q is coming up. Therefore, 16 divided by 1 is understood, log 16. Therefore, first you just calculate 2.303 divided by 60. You are getting some value, just put it and into log 16 value is 1.204. Log 16 value is 1.204. 1.204. And this division is 0.0383. 0.0383 this value, and multiplying this one we are going to get 0.0461. 0.0461. If you keep the value final answer up to here means there is no problem, they are going to give you the marks, and this is the time is in second. But better, while writing this final answer, first you have to keep that. First place you have studied that, you have to keep that in a scientific notation. Means first you have to write by using non-zero term. Means these are the initial zero are there. The first non-zero term is nothing but apart from zero, the number is 4, 6, 1 are there. I am going to shift this decimal point to the after 4, means it is shifting 1 and 2. Therefore, 4.61 into 10 raised to. Can you see here? This is lower number, less number, this is greater number. If number is increased means you have to decrease the power. How much? Digit I have shifted 2 digits. Therefore, I have to write -2. If the number is reduced, you have to increase the power. If the number is increased, you have to reduce the power. You should remember this very smart key point to write the powers. Therefore, time is equal to 4.61 into 10 raised to -2 second is required to convert the initial concentration to its 1 by 16 time. Okay? So this is the important, and sometimes it will be asked for 2 marks. But don't neglect, because it's very much hard. Within 1 minute you can able to solve this problem, but you should have some practice. Practice makes you perfect. Therefore, practice it, don't neglect the problems. It will help you to reduce the time in your exams. Okay. So by this we will conclude the today's video class. No doubt it's little bit slow, and for your kind information, the next class will be the last class. So in that I am going to solve some more problems. So before I move to the last problem, if you are having any doubts in particularly theoretical part, even though if you are having any problems, you can ask that only. So mainly I am giving in theoretical part, you may have some doubts and anything. So if you are having any doubts, feel free, and I am giving you this time. Before I end this chapter, means in the next video I am going to end this chapter. So before that, if you are having any doubts, you just ask me, and you are getting still more very much difficulty means we will do some arrangement or somewhere. If you come here means I am also ready to solve your problems, and if you call or message means I will be there to clear your doubts. Okay, so keep in your mind the last next class will be the your last class. Okay, so we will meet in that last class. Until have a nice day. Bye.